So hello to everyone. I'm pleased to be here for the first time in Prague. It's my B-sides number 8 around Europe. And I would like to introduce a different kind of approach regarding the cybersecurity in OT domain. Briefly, I introduce myself. I don't know where I can stay on stage. I'm an offensive researcher in OT domain. I have more than 25 years in OT. It's a very long time. And especially I developed the SCADAsploit is a command and control for OT adversarial simulation. Currently, I'm the director of OT cybersecurity in EY advisory in Italy. I live in Turin. And more or less it's all. I presented SCADAsploit in besides Black Hat Europe, London, 2 years ago. And last year in the SANS ICS summit was a very interesting experience for me. So before to introduce this SCADAsploit, I would like to put some questions, some important notice I think is relevant for all in order to have a baseline of knowledge related to OT. So why operational technology, cybersecurity? It's very easy. The answer, ICS is a very interesting target for APTs. It's easier. It's very impacting in economic stability, national security, human and environment safety. And the targets are energy, transportation, are telecommunication, but also manufacturing, big manufacturer. And it's very interesting. Some characteristics of OT domain are very, it seems are specifically developed for attackers. Because insecure by design in OT is a standard. So it's very funny for attacker. It's not so hard, and the results are very interesting. Also only for the attacker, not for the companies, of course. So I don't want to bore you with Stuxnet. Stuxnet, I would like to underline only 2 topics regarding Stuxnet. But first, Stuxnet, as you know, is the first malware, or better, is the first cyber attack against OT instructor in 2010. Stuxnet was able to damage the nuclear plant of Natanz in Iran. And this is the first topic, interesting topic. First attack against OT. Second interesting point. Stuxnet demonstrates that it's possible to damage something using software. Before Stuxnet, malware and attacker were target to steal information or to grab dollars and money. But with Stuxnet, they was able to damage something, a physical plant, using software. This is interesting. Stuxnet was the first. Is in 2010, but the hacker team, NSA, it's possible that could be NSA, tried before in 2007, then they restart with a new version, and then the final goal was reached in 2010. Good, but Stuxnet is not the only malware targeting OT, specifically developed for OT target. Another malware interesting for OT is Industroyer. Industroyer in the end of 2016 was able to destroy a power plant in Ukraine, in Kiev. Same result, more or less the same approach. Industroyer is a specific malware targeting power plant generation. Why it target? Or better, how it target energy plant? Because it uses typical communication protocol used in this kind of plant. That means protocol used to control water, gas, critical manufacturing, some electrical switches and so on, that use this kind of protocol. An Industroyer is able to target, to identify the correct target in terms of PLC, DCS, and SCADA system, and apply the attack. Of course, in Destroyer V2 reborn in 2022, a better version with some improvement, of course. Another interesting malware that I would like to present to you is Triton. What's Triton? Or better, why Triton? In industrial plant, there are some strategic components that are called SIS. That means Safety Instrumented System. When you are in production plant and there is an emergency situation, you have to put in the safe situation your plant. And there is some emergency red button to stop the production or to plant the production, to put the production in a safety situation. This situation, these equipment are called, as I said, Safety Instrumented System. One of the most important company worldwide is Triconex that produce this kind of object, this kind of safe PLC that you can put in your plant. Triton is able to attack the specific version of Triconex SIS. That means that when you are in an emergency situation, you go fast to push the red button, and then Triconex, or better, Triton, is able to do the exactly opposite of what is safe. That means that it can, I don't know, destroy or bypass the emergency situation. The consequence could be absolutely catastrophic. It's the end of the plant. Interesting, but not so funny. So what's inside an ICS system? ICS is Industrial Control System. You know, very basic information. I have this slide in order to check if I know the right version of the ICS. So please correct me if I'm wrong. So starting from the bottom, this is a part view model. Level 0 is the process, sensor actuators. Then you have the level 1 is the process, the PLCs and control system. Then you have level 2 are the software that handle the plant and control the plant. Then you have level 3 with operational and control database and so on. Sometimes you can find a strange part that is called DMZ. Very, not so often, okay, I can say. The level is the 3.5, it's called 3.5, and then you have the enterprise, but okay, it's not our domain. So starting from the level 0, you can find the sensor actuators. Sensor is something that can transform a physical value in a digital number. Temperature, pressure, I don't know, speed, and so on. Actuator do exactly the same. Transform a digital value to a physical action. This is the level 0. Then we have a PLC, Programmable Logic Controller. That means it's a strange equipment that control, or better, get the information from the sensor, elaborate the process, the program inside, and then activate the actuators. It's very easy. And then communicate with other devices and do something of strange that can be useful for the plant. Then we have the HMI. HMI is human-machine interface, are some industrial equipment to interact with the operator. And then we have the SCADA. SCADA is supervisory control and data acquisition. It's a software inside a computer, standard computer, in the control room that control the plant, acquire information, send recipes, send historian, send or better, get alarms, store all the information in database and so on. This is generally speaking, is a standard configuration of an industrial plant. But what's a PLC? The dark side of the force. PLC is a strong equipment. It is something absolutely unknown for the most of the expert, IT expert. But it's absolutely a basic embedded Linux system in most of the case. That means PLC is a computer with a sort of Linux or Linux-like operating system with real-time capabilities, without monitor, without keyboard, without mouse. Sometimes you can find a USB port. Backoff is a producer that put inside the PLC a USB port. I don't know why, but okay. But it's a computer with industrial capabilities. That means industrial grade in terms of temperature, in terms of power supply, in terms of humidity, but it's a computer. And inside a computer, you can find more or less Linux-based operating system. For example, Aaron Bradley, very long story, Micro OS 9 is a version of Linux kernel. B&R, producer Wixworks. Wixworks is a standard Linux used in real-time application. Wixworks is used also in aerospace, for example. It's used for industrial equipment, generally speaking. Rockwell, in the control logic, use Wixworks. Schneider, I worked 15 years for Schneider Electric, so I know a little bit in details. And it uses Unity OS, Linux OS. Wixworks, Schneider in old version. Siemens S7 1200, 1500. It uses Adonis. What's Adonis? Linux. And then we have some strange equipment called WinIC. Is a mix of industrial computer and PLC in the same box. Use Windows real time. It's very funny. And then Vago, it's used Linux realty. So why I use this slide, or I would like to underline the presence of Linux? Because if you are a very expert in embedded system, you can also are expert in OT and PLCs. More or less the same. The approach is the same. I show you. If you take a Siemens S7 1200 PLC, it's a small box, compact PLC. The price is around 500, 700 euro, up to 1,000, no more. You can open this picture. I did it. You can open the Siemens, and inside you can find a very simple CPU that is called ARM Cortex R4, that is the same CPU of the M4, but with real-time capabilities. Cortex M4 maybe could be possible is inside this one. It's very simple chip, very low price, used for, I don't know, Cortex M4. Arduino, do you know Arduino? Electronic device for IoT, for the garden, or for the light, and so on. Okay, use M4, Cortex M4, for example. The R4 version is the same, with the same subset of register information, but with real-time capabilities. That is more reactive, okay? But it's more or less the same. Cortex R4 is also used for embedded application, automotive, I imagine, or mass storage, if you have, I don't know, NAS, or industrial microcomponents. It's very interesting because when you put this object, this device, to control your plant, you don't have a octa-core with, I don't know, 32 gigabytes of RAM with high performance, multi-threading, multi-processing. No, you have a very simple and small CPU, monocore, or dual core sometimes. It depends if you want to pay more. You can take the 1500 PLC version that is more powerful, 2-core. No, not bad. But the level, all the applications that run inside the PLC are handled by this small chip. It's very small. The image is big, but the CPU is very small. That means that this CPU is able to communicate using, I don't know, Profinet, S7, or the industrial protocol for the Siemens. Handle the application. That means read the input, elaborate the program, activate the output, and then again for 30 years, maybe. Has inside a website. Why a website? Because Industrial 4.0, technology, IT, you can browse your PLC using a standard browser. You don't need to have the specific engineering software that in Siemens is called TIA Portal. You don't need it. You can open the browser, put the IP address, and then you jump inside the PLC. Not completely inside, meaning a page inside the PLC. But the web server is handled by the small chip. That means that if you are on the network, you are on the OT network. You are connected in Profinet, Modbus TCP, or Ethernet TCP, OPC UA, what you want. No worries. If there is a switch with a port, you can connect your PC. And then you can do an Nmap scan. It's very easy, very simple. You can do an Nmap scan using a T4 parameter, very aggressive, very strong. You can put down your PLC in maybe 5 seconds, no more. Because this PLC is not able to handle all the special crafted requests sent by Nmap and in an aggressive way, because the CPU is alone. It has to communicate, it has to control the process, it has to the web server. It's very complex. Adonis. This is Adonis. You can revert the firmware of the PLC. It's not so hard, it's funny. And you can find the extractor of Adonis. Adonis is the operating system, is a Linux-based kernel, separating two libraries, two services. I say, okay, the light is impossible with the screen. On the left, you have all the operating system services to control the file systems, communication, and all the device. On the right, you have all the automation-related services. That means the application services provided by Siemens. That means Siemens, I don't know, Control IO, Alarm Subset, or automated web programming, as I said before, the web server inside and so on. But if you are talking about a standard Linux, more or less a standard Linux kernel, we can use the same approach to attack this kind of hardware. For example, for the web server, if you run, you can open the browser, as I said before, put the IP address, and you reach the PLC. Then, what you can do? You can open a terminal, and you can use your DIRB, Dearbuster, Nikto, GoBuster, standard pen tester tool, use it in IT, and you can find interesting command and, in this case, using Barbsit, you can find some GET request handler to discover something that can be interesting for an attacker, not for the Siemens or for the user, of course, but okay. And you can find some command that you can use to interact with the device, to grab more information provided as a standard. Okay? Another important point is a Linux. And the applications are sandboxed. That means every application, in this case, the standard application, are in a sandbox. But as a standard approach, you can have, or you can find, for example, some vulnerabilities, as in this case, is a sandbox escape. That means you can bypass the limitation of the sandbox, and then you can reach other part of the memory, or the part of the file system, or the part of, I don't know, of the system. Okay, you can say, oh, this old CV is 2020. Now we are in 2025. Okay, consider that PLC, the life cycle of the PLC is more than 20 years, 30 years, sometimes 40 years. And in some cases, the PLC are never stopped. That means that they work 24 hours, 7 days, 375 days by year, without stopping. And it's not so easy to update the firmware. Even if you find the vulnerabilities, and sometimes, I don't know, someone tell you, guys, there is a vulnerability in your PLC, please update. Okay. Next time, that means, I don't know, 1 year later. Because when you update your firmware inside the PLC, you have to do two important things. One is stop the production. And if you are in a standard or low-level manufacturing plant, there is not a problem. If you are, I don't know, in a critical situation, you cannot stop because it's more expensive. Sometimes 1 day of stop of a plant means $1 million. Okay? So it's very hard to stop a plant, to update and solve a potential vulnerability inside the PLC. Okay, I know, but I have to work. Business is business. The second point, when you update the PLC inside the firmware inside the PLC, you have to recheck all the plant, retest all the plant, because a new feature or new version of firmware can introduce a different behavior. In industry, it's absolutely standard. Okay, so it's very expensive. It takes a long time to do that. So customer prefer to, okay, cross the finger. I know that there is some vulnerabilities, maybe, but okay, we are lucky. So why a C2? Generally speaking, a command and control is very interesting to evaluate the posture, the cybersecurity posture of the infrastructure. IT or OT is the same. So adversary simulations, this is a standard kill chain, is a Lockheed Martin cyber kill chain, is a standard approach. When you do a pen test, you have the similar or the same approach. That means you have a recognition phase, the first, grab information, browsing or scanning the network, finding some vulnerabilities, using map, using, I don't know, Nessus, using Tenable OT, or specific for OT, you can find the Tenable OT, of course, Clarity, Nozomi Guardian, I don't know, Radiflow, IC, there's a long list of potential technical provider of tools, or SCADAsploit. Why not? Okay, but okay, you can grab information on the network. Then you have a second phase is a weaponization. That means, okay, I found some vulnerabilities. Now I prepare my exploit to take the advantage or to exploit the vulnerability. Then I try to deliver my tools, my exploit, my beacon, my stage. Then there is exploitation phase, installation, command and control. When you reach the level of command and controls, means that you have the total control of the target. And remotely, with a very simple user interface that is called remote commander, you can interact with the target, with the victim, doing lateral movement, pivoting, grabbing information, and so on. I will show you in a video. Why adversarial simulation in OT? Because sometimes when you scan a network searching for vulnerabilities, you are not able to really understand the real posture of the cybersecurity. It's a realistic threat scenario that can find the real potential attack vectors, not only the potential in terms of theoretical vulnerabilities. It's a response evaluation. Sometimes, in Italy, we use this approach in many plants, in many situations, and sometimes it's used also for SOC assessment, Security Operations Center assessment. That means, okay, our detection system, our configuration, our analysts are able to find and to interact and to identify potential threat in real time? Maybe yes, but you have to test it. Maybe yes is not the right answer. You have to evaluate. Because if you don't do it, someone else will do. Okay. So how a command and control works, generally speaking, you have a team server. Sometimes the team server is a web server, is a standard web server. I don't know, that sell a t-shirt, for example. So you can reach this website and you can find the standard website. When you interact with the website using a specific get and post header, you have access to a backend that is the team server. That's why it's not so hard, and it's not so easy to identify team server on the network. They are present, but they appear as a standard website for travel, for buy, I don't know, for social, for example. But in the backend, they are team server for command and control. We have the commander, remote commander, to interact with the team server. And then we have the agent, or beacon, or stage, I don't know, you can call as you want, but it's a small software that affects the victim and communicate with the team server, exchanging information in different protocol, HTTP, HTTPS, DNS over HTTPS, for example, and interact with the team server. The attacker has a list of the victim, and then decide, okay, I want to interact with this victim, I want to grab information, I want to steal information, or get, I don't know, some screenshot, or use the victim as a pivoting computer to reach other computer on the net, or you can approach using external C2, for example. You can use OneDrive, Drive, Slack, Teams to communicate with the victim. It's more difficult to find, to identify this path, but it's absolutely common using the command and control. This is more or less the standard architecture of the command and control. So why a C2 for OT? As I said before, this is a standard architecture, level 0 up to level 5. The dream here in yellow, the channel is industrial, and the pink is the corporate. And some vectors, standard vector used by attackers to attack plant are, for example, insecure Wi-Fi connection, of course, supply chain attack. If you are a big company, maybe you are strong in the cybersecurity, but your supplier is a small company that produce, I don't know, a very small machine, and be not so strong in the cyber. So usually attacker can try to grab the credential of the third-party supplier to reach and to go inside the network. Inadequate access rule, internet insecure, internet connection, phishing, and so on. And another interesting behavior, strange interesting behavior in OT is, of course, the infected USB. USB in OT is absolutely common. You need to have, I don't know, a manual. You need to transfer a file from one machine to another. You need to, I don't know, to store something. USB absolutely used in OT domain. And the other one, the last example, is an infected laptop. That means I'm a maintenance, I'm a programmer, PLC programmer. I need to change the, I don't know, 2 lines inside my PLC. I use my standard laptop that usually I use for email, for Teams, for download, for navigate on the internet. Then I go to the plant, I connect my computer to the PLC, I change the software inside the PC, and then I come back to my office. In this case, I bypass all the potential DMZ, firewall rules, ACL, I don't know what, because I use the same physical PC that I use in IT domain, I put it in the OT domain. Yes, but I have the ADR inside. I have a very strong antivirus. Yes, it's true. But sometimes the malware is targeting the OT domain. That means behavior analysis doesn't work, because it's able to identify that is in IT domain, so it's absolutely quiet, it's not active. But when you put your computer in the OT domain, the malware is able to identify the industrial protocol like Modbus, ICS, Modbus TCP, or Profinet, or DeviceNet, or other industrial protocol, and then the malware wake up. Okay? So SCADAsploit is a command and control that you can use for adversarial simulation in IT, but I developed around 100 modules, auxiliary and exploitation, that are targeting OT domain. That means that is able to bypass ADR up today, tomorrow could not be true. AMC, ATW bypass, anti-sandboxing, anti-debugging, and so on. But what is absolutely important, that is the post-exploitation, the arsenal of the database of the modules is targeting 10 minutes, thank you, is targeting PLC producer like Siemens, Schneider Electric, Rockwell, ABB, and others. The dropper file, how to compromise the target. The dropper, you can drop using file-based dropper or PDF. A PDF is more or less the 65% of the dropper today in IT domain. Okay. Then Office X. You can use some interesting approach using XLL to bypass the protection of Microsoft. USB, web, so you can, this is a typical approach used in a SOC assessment that we did last year, using, for example, an OpenXLL that was able to bypass the mark of the web, for example, and is not a macro, is a DLL for Excel, and is accepted by Excel, by Microsoft, by Windows, by the user, usually. And it's interesting. So a demo. I have a video here with 3 virtual machines. Go ahead. Very quickly. The video is 25 minutes. No, I'm joking. No, it's 5 minutes. So we are in time, absolutely in time. So this is a virtual machine with Windows 11. Updated, okay. I showed you that I enabled the Defender and another ADR that I don't want to show you. But okay, the real-time protection is activated. Then, sorry, can you see? Okay, more or less. Okay, I can do that. It's better. Yeah. So, on the left we have a simulator, PLC simulator inside the virtual machine. On the right, we have another virtual machine, Linux virtual machine with the HMI simulator. Okay? This is the remote commander of SCADAsploit. I have the same logo here, so I believe in the project, I think, more or less. This is the command and control, the remote commander of the SCADAsploit. You have, sorry, very quickly. Before very short introduction. The team server is something that is run on the website, okay? And is always always is listen for a victim. So you have to create a listener using a different protocol, different IP address, a different port, and is wait for a victim. Then you have to create your malware, your stage, to compromise the victim. There are some parameters you can select. Usually we use Windows shellcode with encryption, with some other parameters. If you want, we can go in deep detail, but it's not so important now. ICS encryption to bypass the ADR protection, the defender protection. Then you can generate your beacon. The beacon is developed in C and R assembly language. Then you can put in your folder. It is my computer, so there is no secret inside, more or less. And you can save your beacon. Now after that, you have to compromise the victim. In this case, you can compromise the victim using PDF and so on, but there is no time to do that. So, very simple. I open a browser. In my computer, I have AppDoc, a web server that you can use in Python. I put the IP address, and then I download the malware. In this case, it's a demo. Okay? I download the malware. Defender ignore completely the malware. It is Windows tell you, do you want to store? Yes, keep away. No worries. It's only a malware. Then I run it. It's very simple. And the magic happened. Boom. This is the victim. Now the victim is connected to the web server, the team server. And now this is a team server, I can interact, different command, I can interact with the victim. I can try to grab information from the PC, I can send some exploit, I can do something. But, okay, I try to interact. Here, I have a list of potential command. Who am I is the first command. And now, this is the information of the Windows 11 in the virtual machine. Okay? The groups, all the information, domain, and so on. Yeah? Then, SCADAsploit, okay, I can grab a screenshot, for example. This is actually the screenshot of the PC, but it's a joke, it's not so relevant. Oh, maybe. Then I can use SCADAsploit in the right version. I mean, I have one PLC and one HMI connected to the SCADA system, my Windows 11. Okay, clear the screen, and then I use a command of scanning. I mean, I reached the target. Now I have to find the OT devices, PLC and HMI. How to do that? There is a command. In this case, I use a Modbus TCP protocol. I use a command that is called OT Modbus scan. I put the address, a range of the address. CDR, that means /24, or in this case, only 2 address. And then I find 2 devices, the PLC and the HMI, exactly with the same information provided by the virtual machine, the simulator. Okay? I found the 2 devices. I go a little bit faster. In my network map, I have the PLC and the HMI connected to the SCADA system, and I can interact with the PLC. For example, I know that this kind of PLC has a vulnerability that I found 7 years ago. So I can use an exploit that can do a denial of service of the PLC. The exploit is this one. I put the IP address on the bottom, and then the PLC, when I run the exploit, the PLC go in crash. It stops. This is a simulator, but I do with a physical device. That means you can stop the PLC, and you can stop absolutely all the communication, all the interaction, all. Okay? Okay, so we are in time. Sorry. So, make it safe. How to do now? It's absolutely important to put in place organization measures, of course, security assessment, risk assessment, business impact analysis, supplier management, policy and procedures. In terms of technical measures, asset inventory, you need to know which kind of IoT device you have in your plant. An important customer in Italy said, I have 500 PLC. Okay, we do an asset inventory and the device was 960, more or less the double. Okay? Vulnerability scanning, network segmentation, monitoring, endpoint protection, secure PLC programming, and so on. There are a lot of standard, industrial standard like IEC 62443 or MITRE ATT&CK for ICS. The knowledge is on the web. It's not so hard. You have only to put information and to want to do that. Awareness of OT security, important of validating is the takeaways, knowledge of how it's very useful, red teaming, and take care of your cybersecurity of your OT system, because if you don't do it, someone else will. Okay? Thank you so much. I'm in time, I hope.